Lesson 12.3, probability. In the last couple lessons we've talked about permutations and combinations, the fundamental counting principle, and today we're going to bring in the idea of probability. And probability is merely a fraction that compares things that you are looking for compared to the total possible outcomes. So for an example, we have when 3 coins are tossed, what's the probability that all 3 are heads? Now, probabilities are percents, they're fractions, they're decimals, and what we're looking for mainly when we do probability is fractions. Okay, that's one way to look at them. Now, 3 coins are tossed. Now, if we look at stages, when you toss 1 coin, there are 2 possibilities, heads or tails. Second flip, 2 possibilities. Third flip, 2 possibilities. So the fundamental counting principle says that there are 8 possible results when you flip those 3 coins. We're looking for one of those, and that's that all 3 are heads. So we would say 1 out of 8. Another way of looking at this, which we're going to have to get used to for notation, is we're looking for the probability of heads, heads, and then heads. And that can be found by taking the probability of heads times the probability of heads times the probability of heads. Again, that's using the fundamental counting principle with probabilities. Probability of heads is 1/2. Probability of heads is 1/2. And the probability of heads is 1/2. These are all independent of each other, mind you. And again, we get the same thing, 1 out of 8. If we use a tree diagram, then we would do this. Heads, tails, the first one. Heads, tails for the next one. And then head, tails for the last one. And then you can see actually what they all are. In this case, it's heads, heads, heads. In this case, it's heads, heads, tails, etc. Oops, that should be a heads. And where this is the only one that satisfies what we're looking for. So 3 different ways to find out the probability of 3 heads. Here's what we're going to combine with what we learned from combinations. We have 26 books, 16 are fiction, and 10 are nonfiction. He randomly chooses 8 books to take with him. Okay? What's the probability that he chooses 4 fiction and 4 nonfiction? So there's 26 books, 8 are taken, and here are our prerequisites. To do this, we first of all say, what's the probability of, how many combinations are there of having 16 fiction and choosing 4 of them? Again, they said there are 16 fiction. In nonfiction, there are 10, and we're going to choose 4 of them. So for each one, for 16 choose 4, it is 1,820. For 10 choose 4, there's 210. And the fundamental counting principle would say to take them times each other. And that would give us 382,200. Those would satisfy the prerequisite of them saying 4 fiction, 4 nonfiction. Now the probability would be to take one more thing into account. How many combinations are there of having 26 books and choosing 8? Well, that is 1,562,275. So the probability would be to take what we're looking for and dividing it by the total. And that is our result. And if we actually do the division, it would be 0.245, or in other words, about 24.5% chance. Okay? Odds. Odds are taking a probability, which they say in this case the chances of a male born living to be at least 65 is 3 in 4, so 3/4 chance. For females, it's 17 out of 20. Now to clarify this, that means 1 out of 4 will die, and 3 out of 20 will die before their age 65. When I talk about odds, odds compare success to unsuccessful, or what you want to what you don't want. So the odds of a male being born in 1990 will die before age 65. Alright, so the odds that they will die before 65 are, well, we said that 1 out of 4 will not survive to be 65. So therefore we will say 1 will die compared to 3 that will live. And that is the odds. So you do not have the total number presented here, but the sum of the two numbers do represent the total. In other words, 4 people. What are the odds that a female will die before 65? Well, we said 3 out of the 20 will pass before they reach 65, therefore leaving 17 that will live. And again, the total of these two numbers is 20. If we wanted the odds that they will live, we would reverse that, 17 to 3. If we wanted the odds a boy will survive to be 65, we would say 3, because that's the ones that will survive, compared to the one that will not. So you have to read very carefully about what they want, what the odds are representing. Here we have a probability chart, or a distribution. It shows that when you roll 2 dice, what the sum will be. So we have everything from a 1 and a 1, giving you a 2, and a 6 and a 6, adding up to a 12. If there are 6 options for the first dice, and 6 options for the second, that means there are 36 possible combinations of dice. And that's where we get the denominators here. But what they've done is they've simplified the fractions. That's why they are not all over 36. Use this graph to determine which outcomes are least likely. Well, the distribution shows that 2 is very unusual, and so is 12, because there is only a couple ways to get those numbers. The 1 and the 1, and the 6 and the 6. So the sum of 2 and 12, and their probability is 1 out of 36. Use the table to find the probability that the sum is 11. Here's the sum of 11, and it's right here, which takes them to 1 out of 18. What other sum has the same probability? 3. What are the odds of rolling a sum of 5? Well, here's 5. It is 1 out of 9. That's the probability. So that means the odds of rolling a 5 are 1 out of 8. Again, 1 is the one we're looking for, and 8 would be failures. So 1 works, and 8 do not. Again, the sum of those two is 9. And this ends lesson 12.3.